Size of each interior angle for regular polygon is 165 degrees. We've been asked to figure out how many sides the polygon has. How do we do this? Well, to do this, we recognize that any polygon can be cut into a bunch of triangles, and the number of triangles it can be cut into is 2 less than the number of sides. So for instance, if I have got a quadrilateral, I can chop it up into 2 triangles like so. If I've got a pentagon, then I can chop it into a bunch of triangles like so. Pardon me. That's not what I meant to draw at all. This is what I meant to do. So now we've got 3 triangles, one over here, one over here, one over here. And the purpose of this is to demonstrate that by picking any one vertex and then connecting it to every other vertex that it's not already connected to, for polygons that are convex, for polygons that are not folding in on themselves, you can always cut it. You can always cut it into a bunch of triangles. A bunch of triangles, the total angles of which encapsulate entirely the angles of the polygon itself. So we just have to figure out the total the sum of the area of all of these triangles. But that's easy enough to do because we know that the sum of the angles in a triangle is 180 degrees. This is demonstrated, which means if you've got 5 sides, but that means you can cut it up into 3 triangles because you're already connected to 2 sides, to 2 points. Now you connect to all the other vertices. That cuts you up into a bunch of triangles. And each triangle has 180 degrees. So if the number of sides you've got going is n, the number of triangles you have is n minus 2. If each triangle has sum of the angles being 180 degrees, the total amount is going to be n minus 2 times 180 degrees. In this case, we know that this number is equal to 165. In this case, we know that this number is equal to 165 times n, because each interior angle, of course, each interior angle is 165 degrees. Therefore, this is the total of all the angles, and this, of course, is also the total of all the angles. So now we just have to solve for n. Well, how do we go ahead and do this? Well, we can ignore the degrees because both sides have the unit of degrees. So the stuff under the degrees equal on both sides. Anyway, let's get to it. We've got 180n minus 360 minus 165n is equal to 0. 180 minus 165 is 15n. 15n minus 360 is equal to 0. 15n minus 360 being equal to 0 means n is equal to 360 over 15. 360 over 15, what is that all equal to? Well, 15 times 2 is 30. Therefore, 15 times 20 is 300. And then 15 times 4 is 60. So we've got 20 and then 4. So this is equal to 24. So n is equal to 24. This polygon has 24 sides.